Hi everyone, welcome to week 5. Congrats on I guess the big first hurdle, the exam, exam number 1. Great job. Overall, it seemed very positive, uh, fairly high average, a little higher than I was expecting. So nice work. Um, and yeah, it's always good to have that first one behind you. I think there were a few technological hiccups, but for the most part, you've done, and you sort of know what to expect moving forward. So you can see the pattern of class, uh, particularly as it'll go between now and spring break. So got about another month, 4 more weeks of a kind of similar routine, some resilience concepts, some resilience thinking, one more quiz and one more exam right before spring break. So let's just get going. So week 5, uh, some more key concepts that will be covered in the reading this week. We'll try to start with thresholds. I know that was part of the exam and part of the studying and thinking up to exam 1, but the week's reading this week get into it in a little bit more depth. Um, Threshold. What is a threshold? They are levels in controlling variables where feedbacks to the rest of the system change. So there are certain important variables uh, that feed back to the entire system. Uh, Crossing a threshold has the potential to alter a system that we depend on. When we're thinking about social ecological systems, those systems are for the ecosystem services they provide. Systems are something that we depend on. Once a threshold is crossed, it's often difficult to cross back. It's often impossible to cross back uh, to the previous state. And the book describes this as the ball in a basin metaphor. You can see there's a multi-dimensional basin, actually multiple multi-dimensional basins. The ball is a system. The basins are the system variables and external conditions. And the ball will move around the basin within some sort of equilibrium uh, until the system variables, so the ball, changes enough, or the basins themselves change, flatten out, move, push the ball into a different basin of attraction. So the ball is the particular combination of the amounts of each of the variables the system currently has. So what are those key variables in the system, and how do what's sort of the whole picture of that system? Both the equilibrium and the shape of the basin is constantly changing as external conditions change, as the system gives feedback. And so within this lens, we can think of resilience as the amount of change that can occur in the basin, so that the shape of the basin actually changes, and or the system's trajectory. So again, thinking about the change in either the basin or the change in the way the ball is moving around the basin without the system leaving the basin. So the resilience is the ability to keep that ball within the basin. The reading emphasizes slow variables, that social ecological systems are often controlled by a handful of key slow-moving variables. This helps us reduce the complexity when we think about how do we understand social ecological systems, how do we study them. Sometimes, certainly in my own work, the amount of variables to consider gets overwhelming. And the real insight here is that actually there are probably a few slow-moving variables that are really key to the system's resilience. So therefore, managing for resilience is knowing the key variables with particular attention to the thresholds of those variables. So there's been some really neat work over the last 10 years or so thinking about what are the planetary boundaries. What are the key thresholds of our Earth system that, if crossed, will cause serious disruption to that system, lower the resilience of the Earth, thinking about the Earth as a social ecological system, lowering the resilience of that. So you can see there, there's a handful: climate change, ozone depletion, ocean acidification, biochemical flows, fresh water, land system change, biosphere integrity. There are a few subcategories, so phosphorus and nitrogen for biochemical flows, etc. And then the job of the scientists are to try to measure those thresholds, measure those, sort of where those levels exist within that range of variation. You can see some of those categories already we're not looking too good. Others, surprisingly, we may be still a ways away from the threshold. So I've mentioned this a few times, but one interesting resilience concept is redundancy. We don't mean by redundancy the state of no longer being needed. So redundancy can be referred to as, often in management, getting fired. But rather redundancy here, that redundant biotic or abiotic functional groups can increase the response diversity of a system. Response diversity is where different species of the same functional group have different responses to disturbance. So that if one particular species doesn't respond or goes extinct, other species that may be quote-unquote redundant within the function they play in the ecosystem are still there. So the more variation you have in those functional groups, the better. So the example here, we talk about coral, the Caribbean coral system. So in regime 1, R1, you have a regime or a system that's dominated by healthy hard coral. These systems are relatively resilient to shocks, such as hurricanes. In fact, they provide quite a buffer, to the overall system during those shocks. You start to see some shift in the variables. For example, the regime 2, this alternate regime, becomes more of a possibility because of overfishing, nutrient buildup. I found this neat interactive sort of data website click there and it will take you to it. It shows overfishing in the Caribbean. So you have changes in the system variables themselves. You can also see changes occurring in the basin, so that the coral regime loses resilience simply by the nature of that system, the basin, changing. So as the coral regime loses resilience and the basin flattens, the figure B there on the right, um, you become more susceptible to shocks. The resilience of the system is lessened, um, and the state of the system is easily pushed into the new basin. In this case, that new basin's an algae-based system dominated by fleshy seaweed. So the reminders for this week: do the readings if you haven't already done so. There is a wiki for the week. There will be no quiz and no exam this week. I will provide more information on the paper for the graduate students and the project for the undergraduate students. If you have any questions about your exam, about the exam grade, please reach out. Happy to talk to you. After Sunday night at midnight, so starting Monday, the feedback, the incorrect answers should be available through eCampus. Let me know if you have any questions. Great. Thank you all. Have a great week. Bye-bye.